Students, in this video we are going to see final set of 3 more special integrals. Before getting into this concept, we will just revise the previous 3 more special integrals because it will be very helpful to understand the formula. The previous 3 formulas are integration of dx divided by square root of a square minus x square, which is equal to sine inverse of x by a plus c. The second one is integration of dx divided by square root of x square minus a square is equal to log mod x plus question as it is plus c. And then integration of dx divided by square root of x square plus a square is equal to log mod x plus question as it is. If you observe these 3 formulas, we have the square root of a square minus x square and square root of x square minus a square, square root of x square plus a square are in denominator, and in the numerator we have 1. Please observe this very carefully. This will be very helpful to understand the next set of 3 formulas. Now the concept that we are going to learn is this. If you observe this integration of square root of a square minus x square dx, you just observe this. In the previous formula it was in the numerator, now it is in the here it is in the denominator, now it is in the numerator. And then integration of square root of x square minus a square dx, if you observe this is equal to 1 into square root of x square minus a square dx. You just observe this. Here 1 divided by square root of x square minus a square dx. This term, this denominator has been brought to the numerator. Similarly here, I hope you can differentiate these set of formulas very clearly. Now I am going to say the answer for this, how to bygot the answer for these 3 formulas, because please observe it very carefully. If you don't observe this, by hearting these formulae will be very difficult. So please observe these 3 formulas clearly. Observe it clearly. If you observe it, x by 2, x by 2, x by 2. Question as it is, question as it is, question as it is. Here we have plus a square, hence plus a square by 2. Here we have minus a square, hence minus a square by 2. Here we have plus a square, hence plus a square by 2. If you observe this square root of a square minus x square, here 1 divided by square root of a square minus x square is sine inverse of x by a. Here you can observe it, the same formula, sine inverse of x by a here. Square root of x square minus a square. Here in the denominator we have square root of x square minus a square means log mod x plus question as it is. Now here also square root of x square minus a square dx, log mod x plus question as it is. And then square root of x square plus a square is there. Now in this formula, integration of 1 divided by square root of x square plus a square means log mod x plus question as it is. Here also you can observe log mod x plus question as it is. Now I repeat it once again, how to remember this formula. If integration of square root of a square minus x square dx is there, mean if these terms are in the denominator, means we should write this extra terms. When they are in the denominator, we will write only this, but when they go to the numerator, we have to bring some more terms here. X by 2, x by 2, x by 2, question as it is, question as it is, question as it is. Here we have plus a square, so plus a square by 2. Here we have minus a square, so minus a square by 2. Plus a square by 2, and then square root of a square minus x square dx is here sine inverse of x by a plus c. And then this one, for this log mod x plus question as it is. For this again log mod x plus question as it is. Students, if you want to know how to derive these 3 formulas, you can see this explanation in Gupta and Bansal book. You can go through it. They will prove it using the by parts. Since we need to cover a lot of concepts within this week, I am skipping this part. If you observe Gupta and Bansal concept, you can very clearly understand it. They used just by parts concept to prove this formula. Now we are going to see different types of model. that can be solved using this technique. The first one is evaluate integration of 9 minus x square dx. Now if you observe this, the square root of 9 minus x square is in the numerator, hence this comes under this formula. Here if you observe it, a square minus x square should be there. This 9 should be converted in terms of square. Hence 9 can be written as 3 square. So 3 square minus x square means it is in the form of a square minus x square. Square root of a square minus x square. When we have this form, the formula is x by 2. Question as it is, here we have plus a square, so plus a square by 2, and for this we will use sine inverse of x by 3. So sorry students, here I made the mistake. Here it should be x by 2, x by 2, and then 3 square is not written as 9 minus x square. Here 3 square is again written as 9, sine inverse of x by 3. It is the direct application of this formula. Again if you observe it, it is a quadratic expression without middle term. So we will use this special types of integrals. I hope you understand the first problem. Now we move on to next question. In the next question, it is evaluate integration of square root of 4x square minus 5 dx. If you observe this, it is a quadratic expression with middle term, hence it comes under special types of integration. And in special types of integration, our coefficient of x square must be 1, but here the coefficient of x square is 4. Hence to make this as 1, we take 4 as common inside the square root. So the question will become square root of 4 into x square minus 4. X square minus 5 by 4. This 5 by 4 should be written in the form of square. Hence we can write it as root 5 divided by 2, and then the 4 that we have taken common can be brought outside the square root. Then we can apply the formula directly. So as I said, if you observe this, we have taken 4 as common. This 4 has been brought outside the square root as 2, and then this 5 by 4 has been written in the form of square, that is root 5 by 2 whole square dx. Now we need to check the formula for this. This square root of x square a square is in the numerator, means we will write x by 2 and then question as it is minus, here minus a square is there, so minus a square by 2 and then log mod x plus question as it is. In place of x we have to put x only. So when we simplify it, we get the final answer like this. I hope you can understand this very easily. Just we are applying the different formula, but all the procedures we are using here is similar to the first set of 3 different special types of integrals. Now we move on to next question, that is evaluate integration of square root of 2x square plus 3x plus 4 dx. If you observe this, here we have quadratic expression with middle term. As you know, this middle term should be removed. In order to remove this square middle term, what we will do is we will use completing the square method. We already solved many problems based on this concept. As you know very well, in the completing the square method, the first step is to make sure that coefficient of x square is 1. In order to make coefficient of x square as 1, we are taking 2 as common from each and every term. So we get this expression. After this, out of this x square we will write x, and then whatever sign is there, it will be written as it is. Then coefficient of x should be divided by 2. Hence here coefficient of x is 3 by 2. 3 by 2 is divided by 2 means it becomes 3 by 4, and then we will write it in the square, and then whatever term is here, it should be written as it is. Here we have plus 2, so plus 2, whatever is there here without considering the sign, we have to square it, and then that value should be subtracted from 2. These are the completing square method concept. You learnt it in 10th standard. And then x plus 3 by 4 whole square plus, we are simplifying this. Finally we are getting this answer. You know that this number constant should be written in the form of square. So this term is equal to x square as per formula. This is a square. So we will substitute this value in the question. So we get this. The square root of 2 can be taken outside the integration. Now we have root 2 into integration of square root of x plus 3 by 4 whole square plus a square. In place of a square we have square root of 23 by 4 and then dx. Now we need to apply the formula. The square root of 2 written as it is, and then x by 2. In place of x we have x plus 3 by 4. So x by 2 question as it is, and then here we have plus a square, hence plus a square by 2 log mod x plus question as it is. In place of x we will substitute x plus 3 by 4. I hope you understand this. After doing the simplification of this, you will get this final answer. I hope you understand this concept clearly and easily, because we solved many problems based on this concept. Now we move on to next formula, that is evaluate integration of x plus 3 into square root of 3 minus 4x divided minus x square dx. In the previous concept we solved this concept in this method. For example, students, here we solved this as linear divided by quadratic. Here linear into quadratic. What we will do is we will take this x plus 3, that will be written as a into derivative of this expression plus b. We solved many problems in this way. So x plus 3 is equal to a into derivative of this quadratic expression plus b, and then x plus 3 is equal to a into derivation of this is derivative of minus 4x is minus 4, derivative of minus x square is minus 2x plus b. After that we will multiply this a inside the bracket, and then we will compare the coefficient of x and constant. We solved many problems using this concept. We are applying the same concept here. On comparing the coefficient of x and constant, we get minus 2a is equal to 1. Here if you observe it, the coefficient of x is minus 2a, here coefficient of x is 1, from which we can say a is equal to minus half. And then when we compare the constant, minus 4a plus b is equal to 3. When we work on this, a value already we calculated, so we are substituting this minus of. When we calculated, b value comes out to be 1. So we got a and b value that can be substituted in the equation 1. So we get this. In place of x plus 3 we can substitute this. So now the question can be rewritten. In place of x plus 3 we can substitute this minus half into minus 4 2x plus 1 into this square root of quadratic expression as it is. Now this square root can be multiplied inside the bracket. So we get minus half into minus 4 minus 2x into square root of 3 minus 4x minus x square dx, and then when we multiply this with 1 we get integration of square root of 3 minus 4x minus x square dx. Now we assume this as integration I. This is integration of this is integration 1, this is integration 2, and then we solve this separately. Now we are considering I1. If you observe this, if we take this quadratic expression as t, and then when we do derivative on both sides we get minus 4 minus 2x, this dx can be transferred this side, we get this expression. We used the same type in the previous two sets of special integrals, and then we can substitute it. In this place of minus 4x minus 2x dx we can substitute dt, and square root of, for this quadratic expression we can substitute t. Integration of square root of t dt is t power 3 by 2 divided by 3 by 2 plus c. In place of t we can substitute this quadratic expression, and 3 by 2 can be written as 2 by 3. This we calculated I1. Now we need to calculate I2. If you observe this integration of square root of quadratic expression with middle term, hence you will use completing the square method. After writing the completing the square method concept, you will use the corresponding formula. I hope you understand all these things. You know all these concepts very clearly. So we are substituting the corresponding values in the corresponding place, and final, after simplifying them we get this final answer. I hope you understand all these concepts clearly. We solved different types of problem in this 3 set of 9 special integrals. In the next video we will see some substitution technique as well as this concept applied problems. Thank you students. Thanks for your cooperation.